Hey guys, it's Mrs. Saller here. A lot of you are out today, so I thought I'd put together a video of what we've been talking about because we're really starting to get into a little bit tougher stuff with this area between curves stuff. So we're still going to be doing area between curves stuff in class today, but what's a little bit different is you're going to notice a lot of the problems we do today that the limits are not given. Unlike yesterday where I told you you're going from x is 0 to x is pi over 4 or from x is 1 to x is 5. This one you're going to have to find it on your own. So let's look at an example. And let's say, for example, they want us to find the area of the region enclosed by the following two graphs. So by the graph y equals 4 minus x squared, which is going to be a parabola shape, and the line y equals negative 3x. So your first step, as always, is to graph this. And again, just a general sketch. We don't have to get super accurate with this. Now we know the y equals 4 minus x squared is just going to be an upside down parabola that's been shifted up 4. So it's just going to be having a y-intercept of 4, and then, oops, that's really bad, guys, sorry, and an upside down parabola that looks like that. So y equals 4 minus x squared is that graph right there. On the other hand, negative 3x is just have a 0 y-intercept, and it has this very steep negative slope. So as you can see, these two graphs are going to intersect, and this is the area we're looking for, that enclosed area between the two. So what we need to do first is we need to figure out where these two graphs actually intersect. So the way we're going to do that is we're going to set the two equations equal to each other and solve. So negative 3x is equal to 4 minus x squared. We're going to solve for x, and that should give us the upper and lower limits for our graph. So it's just a quadratic that we can now solve for. So we have x squared minus 3x minus 4 when you get everything on one side. Factor. So x minus 4, x plus 1. And we do expect two solutions. We have two intersection points. So x equals negative 1 and x equals 4. So this must be the negative 1 over here, and this must be the 4. And it kind of makes sense based on our graph. So now we're ready to actually come up with the calculus for this. So let's take the integral between our negative 1 and 4. The top function is the parabola, so that's the 4 minus x squared, minus the line, so minus a negative 3x will actually turn into a plus 3x at the end there, and with respect to x. And that just turns into an everyday calculus problem. So take the integral, and you have 4x minus 1/3 x cubed plus 3 halves x squared. And we're going to evaluate that from negative 1 to 4. And now plug in 4. So you have 4 times 4 is 16. Minus 4 cubed is 64, so you get 64 thirds. Plus, when you plug 4 in here, you get 16 times 3 is 48, divided by 2 is 24, so it actually turns out pretty nice. Minus, when you plug negative 1 in, you get negative 4. Then you get negative 1 times a negative 1/3 is positive 1/3. And then plus 3 halves here at the end. Okay, so now let's add like things here. I always say wait to do the common denominator till the end. So 16 plus 24 is 40. Plus 4 is 44. And then you have 64 thirds, negative 64 thirds, minus 1/3, which is negative 63 thirds. And then you just have that random minus 3 halves there at the end. So what this turns into is you have 44 minus, that's nice, that's 21, minus 3 halves. So you get 23 minus 1.5. So you get 21.5, and you've now just found the area between those two curves. So actually not too bad. So really the only thing we're adding on to today, guys, is actually finding the endpoints, so the upper and lower limits for that graph. Now let's change it up just a little bit, and let's suppose instead that we want to actually find, let's see where I'm at right now, that we actually want to find the area between two curves, but this time we're not going to be able to find the areas by hand. Okay, so what we're going to do is look at a slightly different one. So same directions, but what we're going to do is we're going to find the area enclosed between these two graphs. So y equals 2 cosine of x, and y equals x squared minus 1. Okay, now actually I can graph this by hand, but then we're going to move over to the calculator, and I'm going to explain why in a second. Alright, but 2 cosine of x, just a cosine curve that has an amplitude of 2. So it's going to start up high, go middle, low. And again, don't get super crazy with the accuracy, guys. A rough sketch is really all that's needed here. I mean, this is probably going to be good enough for me. And then x squared minus 1, just down 1, normal x squared curve, like that. And then again, just like the last example, we're not giving endpoints, but we can see that that's the area we're looking for. So we need to find these left and right bounds here. So we're going to set the two equations equal to each other to find where they equal, when do they meet up. But this is not going to be easy to solve by hand. In fact, I'm not even really sure how you're going to do this by hand. We're going to need to use our calculator. So how are we going to use our calculator? We'll plug this guy in for y1, this guy in for y2, and let's intersect them. So let's go to our graphing calculator. Make sure you're in radian mode before you start, and go into y equals. Clear all this out. And we're going to do 2 cosine of x, close the parentheses, and then the x squared minus 1. I'm going to change my window up a little bit. I'm going to go between -5 and 5 for x, and then for y min, y max, I really only have to go between -2 and 2, because that's the highest and lowest cosine ever goes. So press graph. Hey, we did a pretty good job with our graph, I think, and look how close that is. Okay, so what we need to do is we need to find this point of intersection and that point of intersection. So second trace, intersect. And let's just find the positive one here first. So get close to it, press enter, enter, enter again. Now we get about 1.265, so let's write that down. But remember, we don't want to be using rounded answers, especially if we're going to be doing this in the integral. So what we're going to do is we're going to go back into the calculator, and we're going to store that. So clear out of the screen, go to x, and what's nice about your calculator, anything you find in the graphing feature gets stored as x. So now let's store that as something else just so we don't lose it. So store it as a. And also when we do the integral later, if you leave it as x, sometimes it messes up the integral with the dx. It gets kind of confused. So put a in for it so it doesn't get confused later. So it's about 1.265 is our a. Now tell the people grading this, which is me or the AP graders, that I'm calling that a. Because then we don't have to write this again. We can just use a anytime we're using that limit. Now, I think that the other intersection point is probably the negative of that, but let's just double check. So second trace, intersect. It looks pretty symmetrical, we should always check it. Enter, enter, enter. And sure enough it is. It's negative 1.265. So that's our intersection point. So now we can set up the integral. So our integral is going to be between negative a and a. So what's nice is I can now use those variables instead of actually using those numbers. Of the higher function is the trig function, so 2 cosine of x, minus the lower function, which is x squared minus 1. Make sure you realize you're subtracting the whole function, not just the x squared. So put that in parentheses. Now, we can actually use our calculators. If we had to use our calculators to find this, we can use our calculators to find this. So let's do that. So go to math, fn int, which is always option 9. We're going from negative a to a. Of 2 cosine x, make sure you close the parenthesis on the angle before you subtract, and subtracting, parentheses, x squared minus 1, close the parentheses, then dx, then press enter, and it'll spit out your answer. So it's about 4.995. Alright, so that's how you do it if you have to use your calculator. So you're going to have problems like this in tonight's homework, and that's like number 9, 7, and 9. In tonight's homework, you may use your calculator. And there'll be problems just like this. Now the last example I want to go through with you guys today is a problem like this. So let's say, for example, we want to find the area bounded by the graphs x equals 3 minus y squared and the graph x equals y plus 1. Okay. Now, in class today, we actually showed that, yeah, you can solve for y, but solving for y is actually not going to make this any better. And you guys can look at the graphs yourself and see what happens there. So what we talked about is how would we graph these the way they are right now. Okay, so if they're in terms of y, so we have a function x with respect to y. What you're going to do is you're going to mark the axes. So this is a positive x-axis, this is a negative x-axis. The positive y-axis and the negative y-axis. And it's kind of hard to demonstrate here, guys, but basically you're going to turn your page sideways so that this axis is pointing up, okay? So you want this pointing in an upwards direction. So literally you're rotating it 90 degrees so that your positive x value is pointing up. Then you're going to graph this guy with that side pointing up, so with this pointing up, and just like you normally would. Okay, it's a parabola, it's moved up 3, and it's opening downwards. So it's going to be going up 3 with this side pointing up, and it's opening downwards. So this is pointing down to me, so I'm going to be going like that. And that's the graph of x equals 3 minus y squared. Now this is a little confusing. For this guy here, This is a line with an intercept of 1, so go up 1. But now he has a slope of 1. So positive 1, you go up 1 and actually left 1 because you want to go in the positive direction. So up positive, left positive. So your next point's actually going to be there. And that's our graph for our line. So this is the area we're trying to find in between these two. So we need to find this point and this point. Now with this sideways, you might start to realize that we want to do this sideways because this function, the orange function, the 3 minus y squared, is always on top of the line. So I'm already thinking I want to set my integral as the top function is the parabola, when I'm looking at it sideways, that's on top, minus the line. Okay, now we do it to find our intersection points, so just like before, we're going to set the two equations equal each other. So we're going to set the y plus 1 equal to 3 minus y squared, and solve for y. So get everything on one side. And factor. And we see two intersection points, y equals -2 and y equals 1. That kind of makes sense. This looks like it's about 1. This looks like it's about -2, so it kind of makes sense to the graph. And that's how you're going to set it up. And that way, I mean, if you look at it the normal way up, where this is pointing up, this would be really hard to take an integral this way with a normal setup, because you'd have this guy, the line, on top for part of it, but then it would switch over to the parabola there. So if you turn it sideways, though, and look at it sideways, the parabola is always on top, the line is always on the bottom. So we only have to do one integral instead of several integrals. So I'm going to stop there, guys, because I think you can probably integrate this by yourself, but that's the setup for how you would solve if it's easier, especially if you can get these functions in terms of y. Just graph it sideways, and then it's pretty obvious that one function, when you're looking at it sideways, is always on top, and one's always on the bottom. That way you're only setting up one integral. So see how this homework goes, guys, and hopefully you can try to catch up with this stuff. We are going to be doing more with this tomorrow in class, with the chapter 7.2 stuff. And of course on Monday and Tuesday and Wednesday next week we'll be doing this as well. So good luck with tonight's homework. If you have any questions, drop by tomorrow morning, Friday morning at any time. We'll be happy to help you, and have a good night.